Okay, so again, we're going to use our product rule because we're multiplying two functions. Okay, so we know that our derivative, instead of f of x, g of x, we can actually just write it as f and g since we know it's a function of x. That's going to equal the first times the derivative of the second plus the second times the derivative of the first. All right, so we know if we want to find our f prime of x, we have to find the first times the derivative of the second. So negative x to the third minus 2x squared minus 2x times the derivative of sine of x plus sine of x times the derivative of negative x to the third minus 2x squared minus 2x. All right, so we go ahead and simplify that. So we have our first minus 2x squared, bless you. Didn't mean that. Times the derivative of sine, which is cosine, plus sine of x times the derivative of negative x to the third minus 2x squared minus 2x. So we bring that 3 down to the front and subtract 1. Minus, we bring that 2 down to the front. 2 times 2 is 4, and subtract 1. And that becomes negative 2. Okay, so for that one, you can leave it that way if you want to. You can switch them. It doesn't really matter, but both of them will be right.
On the test, we would just kind of leave it that way or simplify it that way.
Oh no, leaving it that way is fine. You don't have to distribute and all that other stuff. That's just extra work. All right, any other questions on that one? All right. And this is the quotient rule problem. I'll start on a new sheet for that one. Leave that up for a few more seconds. All right. Okay, so let's say, for example, if h of x is equal to f of x over g of x, where our f of x is equal to negative 5 cosine of x, and g of x is equal to x to the third minus 2x squared minus 4x minus 1, what is h prime of x?
Pretty much we're doing the exact same thing we did in the last section, last class, but instead we're adding trig functions.
Exactly. Yep, steps are exactly the same. Okay, so using the quotient rule, so pretty much our f prime of x is going to equal our denominator times the derivative of our numerator minus our numerator times the derivative of our denominator all over the denominator squared. Okay, so that means our h prime of x will equal our denominator, which is x to the third minus 2x squared minus 4x minus 1 times the derivative of our numerator. So the derivative of, let's say, negative 5 cosine of x prime minus the numerator, which is negative 5 cosine of x, times the derivative of our denominator, x to the third minus 2x squared minus 4x minus 1 prime all over our denominator squared. X to the third minus 2x squared minus 4x minus 1 squared. Okay, so now we just simplify our derivatives. So we have x to the third minus 2x squared minus 4x minus 1 times the derivative of cosine is negative sine, so you end up with 5 times negative sine, which is 5 sine. Sine of x. Minus, you have negative and negative here, so you might as well make that positive. 5 cosine of x, and I'll go ahead and block that out, times the derivative of this function, which is 3x squared for this one. Bring down our 2, we have minus 4x. This one becomes minus 4. That 1 disappears. That's all over x to the third minus 2x squared minus 4x minus 1 squared. Okay, now if you wanted to, like I said, you can switch them around and everything else, but this is actually just fine. So let's say h prime of x is equal to 5 sine of x, x to the third minus 2x squared minus 4x minus 1 plus 5 cosine of x times 3x squared minus 4x minus 4 all over x to the third minus 2x squared minus 4x minus 1 squared. Like I said, all that does is just kind of move that to the front and neaten it up, but move that up some. It's not really necessary. All right, any questions on that one? All right, I'll leave that up there for a few seconds.
So,
Mhm.
so the derivative of sine is cosine at the negative.
Yep, derivative of sine is cosine. Derivative of cosine is negative sine. Yep.
And then derivative of negative sine is back to.
Yep, derivative of negative sine would just be derivative of, well, -1 times the derivative of sine, which is just negative cosine.
Yeah, and then when it goes back in the same pattern.
Yep, it just kind of repeats.
I was wondering, I saw a pattern there, and I was just trying to make sure.
Yep, actually that comes in handy later because we're going to do stuff like derivative of sine of to the 48th, like the 48th derivative and stuff like that. So that pattern actually comes in handy.
And then, are we doing any like derivative of like tangents and stuff? Or?
Yep, actually we're doing that next. So we have tangent, secant, cotangent, and cosecant. All right. Okay, so we had 1 and 2 were sine and cosine. Say the third one, the derivative of tangent equals secant squared x. Derivative of cotangent equals negative cosecant squared x. The derivative of secant x is equal to secant x tangent x. And the derivative of cosecant of x is equal to negative cosecant of x, cotangent of x. actually, if you look at them, it's a little bit of a pattern. Because tangent is secant squared. Cotangent, cosecant squared. So those two are just co-opposites of each other. You have tangent, you have secant. So if you can remember tangent,
Yeah, I see that.
it's secant squared. Okay, cotangent, cosecant squared. So the two co's are together. Same thing here. Secant
Okay.
is secant and tangent. Cosecant is cosecant and cotangent.
Which is adding negative in front
Yeah.
of it.
Yep, just the negative in front of it. So actually, the two co-derivatives are negatives.
Yeah.
So it's like little things like that to kind of help remember them.
Cosine is also negative, right?
Yep,
Derivative
cosine. Yep, your cosine is negative sign. All right, so proof of derivative of tangent equals secant squared of x. Okay, so for this proof, you just have to remember the little replacement that tangent of x equals sine of x over cosine of x. Okay. So that means the derivative of tangent x is equal to the derivative of sine of x over cosine of x. Okay? And there we can just use the quotient rule. Okay, so move that over a little bit. So you have your denominator times your derivative of your numerator minus your numerator times your derivative of your denominator all over your denominator squared. All right, so that gives us, we'll move that up just a smidgen. Cosine of x times the derivative of sine is cosine minus sine of x times the derivative of cosine is negative sine all over cosine of x squared. Okay, so cosine times cosine is cosine squared. Sine times sine is sine squared. The two negatives become positive. All over cosine squared of x. Oh, sorry about that. Okay. Now, if you remember, cosine squared plus sine squared is equal to 1. So that leaves us with 1 over cosine, clean that up, squared of x. Okay? Since 1 over cosine is equal to secant, 1 over cosine squared is equal to secant squared of x. All right. Any questions on that one? All right. Okay. Now the other proofs I'm going to include in your notes, but we're not going to go over them in class, but they will be included in the notes. Actually, let me add them now because I put them here for that reason. so I will not forget them. There we go. All right. Okay, so let's say for example, what is the derivative of f of x equals -5 cosecant of x minus 4 secant of x? Oops, room for a question mark. All right, so solving this is just like solving the others. F prime of x is just going to equal -5 times cosecant of x prime minus 4 times the derivative of secant of x. Okay, so that's just going to equal -5 times negative cosecant cotangent minus 4 times secant of x tangent of x. Negative and negative is positive, so our f prime of x is equal to 5 cosecant cotangent minus 4 secant times tangent.
We're not going to double prime, are we?
Oh, no, not for these.
Okay.
If going into double prime, then you'd have to worry about the product rule here and the product rule there. That'll get lengthy. You will eventually, but not.
Not in this class.
Yep. Hold on, were you in this class? I think we might cover that in this class. Can't remember. I think it is in. Yep, I think it is in this class. But just later on. All right, so I'm trying really hard to zone him out here.
Tell me about it.
All right, so let's say we want to find the derivative of f of x equals -2 cotangent of x plus 3 cosecant of x. All right, now I'll give you a few minutes to try that one on your own. right, so for this one, to find our f prime of x, it's going to equal -2 times the derivative of cotangent of x plus 3 times the derivative of cosecant of x, which gives us -2 times negative cosecant squared of x plus 3 times negative cosecant cotangent. Okay, which equals negative and negative is positive, so you come up with 2 cosecant squared of x minus, since that's a negative, we just pull that negative out to the front, 3 cosecant cotangent. All right, so any questions on that one? All right. Okay. All right, so let's say, for example, you wanted to find the equation of the tangent line to the graph f of x equals cotangent of x at x equals pi over 4. Okay. So whenever you see a question that asks for the equation of the tangent line, you're going to use the point slope form, which is y minus y1 equals the slope times x minus x1. Okay, that means you're going to need an x1, y1, and you're going to need your slope. Okay, to find your x1, y1, or in this case, our x1, f of x1, we're just going to plug in our x equals pi over 4. X equals pi over 4. So that gives us f of pi over 4, which is equal to cotangent of pi over 4. Remember, cotangent is cosine over sine, so cosine of pi over 4 and sine of pi over 4 are both equal to the square root of 2 over 2, which gives you 1. So your x1, y1, is actually equal to pi over 4, 1. Okay, so we have our point. All we need is our slope at pi over 4. Okay, so we have our x1, y1. Find your slope at x equals pi over 4. Find f prime of x, which is equal to derivative of cotangent. We know that's negative cosecant squared. Okay, so now we just have to find the slope at pi over 4. Equals negative cosecant squared of pi over 4. Now if you think of it this way, cosecant is 1 over sine. So sine of pi over 4 is 1/2. So we have, let's write it out this way. Cosecant of x is equal to 1 over sine of x. So since sine of pi over 4 is equal to 1/2, cosecant of pi over 4 is equal to negative 1/2. I mean, square root of 2 over 2. Sorry about that. So it's 1 over square root of 2. Okay. So if you square that, it's actually negative 1/2. Oh. Sorry, that should be flipped because it's flipped here. So negative, positive, it's negative over here. There we go. So now once you square it,
So that's a positive.
that would just be equal to 2. So it would be negative 2 only because of that negative right there. So f prime of pi over 4 is equal to negative 2. All right, so we have our slope. We have our slope, and we have our point. Okay, so we just plug it in. Y minus y1 is equal to our slope. You can put m here, or you can put f prime of a, whichever one. I just put that just because it's familiar. Okay, so that's y minus your y1 is 1 equals your slope times x minus x1, so x minus x1 is pi over 4. Okay, so that's y. If we add 1 to both sides, well, actually, let's distribute this first before we do all that. Y minus 1 is equal to negative 2x. Negative 2 times pi, that becomes positive.
Pi over 2.
Yep, pi over 2, because 2 pi over 4 just becomes pi over 2. Okay, so just add 1 to both sides. You have y equals negative 2x plus pi over 2 plus 1. You can leave it like that, and that'll be just, oh, move that up some. And that'll be fine. You don't have to combine the pi over 2 and 1 if you don't want to, because it would just be pi plus 2 over 2, which really isn't that much better. So that is actually okay. All right. So any questions on that one? So it's a lot of going back to trig once you start plugging in values. So
Love trig.
I know, I thought trig was fun too. Yeah.
You said that it would just equal 2 pi over 2, right? And then if you plug the 1 in,
Which one?
add it, pi over 2 plus 1, that would be 2 plus pi, oh. Right.
Yep, pi plus 2 over 2, which,
You can't necessarily.
I mean, you can do it. It's just not, you don't have to. So if you wanted to, just to make it smaller.
But wouldn't that just equal pi?